Okay, so we've been learning about all these radical expressions and how to simplify them, how to add them, how to subtract, how to multiply, how to divide. Okay, and again, that's the foundation so that we can develop our radical equation. Okay, what makes it an equation? Simply that there's an equal sign and that it equals something. Okay, so here's the step-by-step on how to solve a radical equation. We'll kind of go through the process, and then obviously we're going to practice a bunch of things. One of the things that is a little bit different, again, when we do square root stuff, you've noticed that like when we were solving for Pythagorean theorem, right? For example, if we had to do the diagonal of a triangle, right? And when we took the square root of it, we introduced two solutions. So when we're dealing with radicals, there's usually the potential for two solutions. So we have to take whatever our answer is, and we need to verify it. Now, maybe in the past, you guys have done, I'm going to say more of a check. In 20-1, we do a verification. It's a very formal process, very similar to when you guys were writing out the transformations, and I wanted like very specific wording, right? Reflection across the x-axis, vertical stretch by a factor of 4 from the x-axis, right? There's, in some things, there's like certain ways to say it in orders. So for a verification, again, there's a certain process that I'm going to show you. It might seem a little formal to you to do it this way, but this is the way that we're going to do it. This is what you're going to see in 30-1. Okay, so it is a little bit more formal. It's not just a little chicken scratch on the side, you know, making sure that your left side equals your right side. Like, it is a formal presentation of your work, and you're doing a verification. Okay, so we're going to walk through that as well. Okay, so as you can see in your notes, the first thing we're going to do is we're going to isolate the radical. So very similar to when we had a regular equation, we wanted to solve for x. We needed to isolate x, get everything else on the other side. So the first thing we're going to do is we're going to get everything else besides the radical on the other side of the equation. So here's our example equation. The root of 4x, subtract 7 equals 13. So you're going to add 7 to both sides. Okay, then what we're going to do is we're going to eliminate the radical. Okay, you do that by squaring both sides. Okay, so eliminate the radical, we square both sides. Okay, this only works when the radical is isolated. If there's like a number hanging off, right, +1, when you square it, you don't like it, okay, then you're introducing a binomial, right, and then you'd have to like FOIL and everything else. That's why we isolate it, okay, so that when we square both sides, our square root, right, resolves because we're squaring it, and then we can solve for x, okay? The verification literally is like a little T-chart, left side, right side. I think maybe in grade 10, we used to like put a equal sign and a question mark above it where we were saying, does the left side equal the right side? Now we're just looking for a little bit more separation, okay? And you never cross the line, right? You never, like when we're solving for the left side, we're not suddenly like adding the 7 over onto the right side. Like the right side stays as it is. So in our original question, the right side was only equal to 13. So we just put 13 on the right side and then we don't touch it. So then when we do our substitution, we show all the work on whatever side requires the substitution, okay? And then we check for, okay, any extraneous solutions. Let me just, okay, I already corrected that. Okay. So in this case, sometimes this is why we do the check. Sometimes there will be an extraneous solution. So we always verify the solutions. Okay, for radical equations, I'm just going to say it again. We always verify our solutions. Okay. So, woo, I didn't want that. Okay. So this is sort of like the restrictions. Do we need to state restrictions? Always. Okay. Do we need to simplify radicals? Always. Okay. Do we need to do a check? We will always do a verification. So yes. All right. So now let's actually do a few of these together. Okay, just an aside, if we're solving for a cube, you're going to do the exact same thing. You're going to isolate for the cube. You're going to cube both sides to eliminate the radical and then continue to solve. Okay, so let's actually, okay, take a look at this one, and we're going to solve an equation with just one radical term. So first thing we're going to do, we're going to state restrictions. Okay, so state restrictions, we're going to do it right here. Okay, so don't forget, when there's something under the radical sign, right, we're going to take the entire radicand and we're going to make that greater than or equal to 0. Okay, so we have x is greater than or equal to 1. That's our restriction. So then we take a look at our equation, and we're just going to isolate for like the radical. So we have x minus 1. Okay. We have the plus 7 is equal to 13, so we're going to subtract 7 on both sides. 6. Oh, my brain's got to kick into gear here. All right. Then, once we have it isolated, okay, we're going to square both sides. Okay, the squaring on this side simply removes the radical sign. So we're left with x plus 1 is equal to 36. Okay, now it becomes a very straightforward equation. Go ahead and solve for x. Okay, x is equal to 35. Okay, yeah.
How do you make it close?
Oh, because I made a mistake. Sorry, guys. Thanks. I told you it's Monday here. All right. Minus 1. That didn't change. Minus 1. So let's go for 37. Okay, thank you. All right, then we're going to verify. Okay, so just put a nice little, okay, I like to label mine that I'm verifying, okay, and then we're going to do a left side, nice little T-chart, right side, okay, and you're going to write the original question. Okay, and then we're going to substitute in. So 37 minus 1 plus 7, 30, root 36, 6 plus 7, 13. Okay, and then you can say at the end, left side is equal to right side. And then actually, after I do my verification, that's when I would come back and box my solution to show that it is correct. So if you have, for example, 2 solutions, we're going to get a little bit more complicated in a few minutes where there are 2 solutions, right? Leave them to the end after you've verified them. Then you can circle and cross out the one that's extraneous and box your solution. And here's something that's interesting. Okay, you can also use your calculators to check. Okay, so if it doesn't ask you to write out the solution, it might say, check your work graphically. So let's learn how to do that. Okay, so what you're going to do is, with your graphing calculator, you're going to, in y1 equals, you're going to put the left-hand side. Okay, and then in y2 equals, you're going to put the right-hand side. Okay, and we're going to check to see where they intersect. Because where those 2 equations intersect, that's the solution. Okay, so looking at the solution, if I have an answer of 37, probably means I'm going to have to change the window settings in order to see that intersection. Okay, so pull out your calculator. Okay, and we had square root of x minus 1. Okay, and then plus 7. And then y2 equals 13. Okay, so if you don't change your settings, okay, this is what you would see. You'd see something kind of like high off and to the right, and definitely no intersection. Okay, so we're just going to have to change our window settings. Okay, and I know that, let's change this to 40. Okay. And what did we have here? We need to, let's do that as well. Let's just see where we're at. Okay, there we go. A little high on the Y. Okay, you can just play with it until there. Well, let's do, I'm just going to make it a little bit more so we can see. Okay, like it's hard to see the intersection. So that's where we go. Second trace to calculate intersection, so number 5. It asks us for the first curve, so you can hit enter. Second curve, hit enter. You don't need to take a guess. And as long as the calculator window can see the intersection, it will give you an answer. Okay, if your window settings are such that you can't actually see the intersection, then it'll give you an error. Okay, so it just is confirming that x is equal to 37 when y is equal to 13. Okay, and we're there, like you might be thinking, oh, well, why is y equal to 13? That was just the right hand side of my equation, right? Okay, we set everything equal to 13. That's where the 13 came from, and our solution is 37. So if it wants a graphical check, you can do it that way. Yes. Okay. Okay. That would be a good thing to do. Like say you had a multiple choice question, say you had a numeric response question. If you're not getting marks for your verification, go ahead and check graphically. Okay? Even if you do have a written response and you're doing your verification, like it takes just a second. You might want to just double check your check, right? As long as it's not adding a huge amount. Okay, so if you're feeling good about this, you're like, okay, this is making sense. Go ahead and do this one. Square root of 7x plus 1 equals 15. Okay, so first thing you're going to do is you're going to isolate for your radical. Then you're going to square both sides, then you're going to solve for x. Okay. So hopefully, again, don't forget state restrictions. I think that's probably when you're doing this, like you're so excited to get into like solving that you might forget that. Okay, so don't forget stating your restrictions. Maybe do it at the beginning just so that it's done. Okay, you isolate for your variable, square both sides. Okay, did my verification, and my solution is x is equal to 28. Okay, now I'm going to show you what it looks like when we have a radical equation with an extraneous root, and then I'm going to get you guys kind of up and going and trying some of these. All right, the next question is the one that we're looking at, solving an equation with a extraneous root. Okay, so first thing I'm going to do is I'm going to state my restrictions. Okay, I take my radicand and I make it greater than or equal to 0. Because I divided by a negative, my sign flips. Okay, so you should have m is less than or equal to 2. Okay, so just make sure that you notice this. All right. So right now, the radical is already isolated. Okay, so we can move right on to the next step, which is to square both sides. So we have m squared is equal to 2 minus m. Okay, when we squared the radical, our square root sign disappeared. Now you guys should be looking at that going, oh, that looks very much like a quadratic. Okay, if I move everything to one side, m squared plus m minus 2 equals 0. Okay, so the first thing I want to do is look at that and say, can I do product sum? Can I just factor it? Because remember, we're solving for m. We're solving for m. So see if you can simplify it first, right? Product sum. So our product is -2. Our sum is 1. and then we have 2 minus -2, okay, which gives us 4, okay, which then is equal, just do this one. Okay. Now here's something interesting, because you might say, well, Mrs. Branch, why didn't you say that the answer was plus or minus 2? Okay, because the square root sign was already there. Okay, it just asked, so if, okay, the question already has a square root sign, it's implying that it wants the positive answer. If you introduce a square root sign, like when you're taking the, like you're doing Pythagorean theorem, okay, you're introducing the square root into the question, and it's giving you 2 possible solutions. This one, because it's already there, okay, my answer is simply positive 2. So this left side, okay, does not equal right side. So this one is going to be straight east. And then we do our check for the next one. Okay, and our next one is 1. And we have 2 minus 1. Okay, 2 minus 1 is 1. Square root of 1 is equal to 1. So this one, the left side, is equal to the right side. So that is our solution. Okay. So a fair amount of work for solving a radical equation when we do everything. Restrictions, isolating for our variable, solving for it, and doing our verification. Okay, so how about you get together with your group, head up to the board, and do this next question. Okay, n minus 2 is equal to -n. Okay, I'll move over on the board. Okay, as we look at this one, okay, the question says, are there restrictions? Okay, what do you think? Any restrictions? Okay, I'm seeing lots of shaking heads. Okay, so why are there no restrictions? You are correct. Why are there no restrictions? Yeah.
Because x is raised to a positive index when it's under a positive index radical.
Yeah, yeah.
Don't know what.
Yeah. This radical sign. Yeah, it has an even index. Okay, and it's an exponent. It has an even exponent. So if you were, right, if you kind of forgot and you just went right to the normal way that we do restrictions, and if you tried going 3x squared plus 2 is greater than or equal to 0, okay, and then you did 3x squared greater than or equal to 2, divide by side here, okay, and you ended up with this, okay, x squared is equal to a negative, right, and you're like, well, that doesn't work, right, that just breaks math. Okay, so what it's saying is, okay, this is impossible, therefore there are no restrictions, right? And you could look at it a different way. You could say, okay, what number could I put in for x? I could put in -100, and it would get squared. Now it's a positive, right? And then times 3, 300 plus 2. There's no number that you can put in there that would ever make that expression negative. Okay, so there are no restrictions, but I'm just letting you know what it looks like when you actually try to like prove that there are no restrictions. It kind of doesn't make sense. Okay, so the conclusion here, when this is impossible, okay, there are no restrictions. Would I need you to go through all of this? No. I'm just saying, if you accidentally do, like you can either say there are no restrictions or you just move on, because we have an even integer with an even index. Yeah.
What if it was like 3x minus? Because then when you did that, you would say 3x minus 2 is greater than or equal to 0. And then we have 3x squared is greater than or equal to 2.
Yeah, if the numbers were slightly different, okay, yeah, you're subtracting a larger number than what you could get here, yeah, then there might be a restriction on it. calculating, it's a good thing to, but here, again, we didn't have to because it was a plus 2. But I see what you're saying. Like if it was, x squared minus 10, there are still some numbers that would give you that. Yeah.
Even minus 2.
Well, no, negative 2 squared would give you 4. Right? 4 times 3 gives you 12, and if that was a minus 2, you'd still be a positive number. But there are some numbers that would give you, like if we did a fraction, a decimal. Okay. So go ahead and, okay. So in this case, right, when we, so our radical is isolated, so that part's done. Okay, now we get a little bit more complex in the sense that, let me get this under a square root sign, 2x plus 1, okay, plus 1, okay. Just don't forget when we square both sides, okay, put everything into a bracket and square it. So now you've introduced this binomial. So you'll need to do FOIL on it. Okay, so common mistakes people sometimes would forget, and they would try squaring the first number and squaring the second number and just shoving them together. That's not how we do squaring a binomial. Okay, so just make sure that you're not making those little mistakes, right? We have 3x plus 2 is equal to 2x plus 1 times 2x plus 1. Okay? And we're FOILing that. Okay? Once we have that, then we're going to make our quadratic equation, and we want to be able to see that equals 0 so that we can factor it because we're solving for x. So I like to keep my leading coefficient positive, so when it's on the right-hand side, I just push everything else on the right-hand side. Okay, so I'm subtracting 3, so plus x, subtracting 2, so plus 1. Okay, so we look at that, we're like, can we factor? Yeah. No? Yes. Thank you. Okay, I wrote on it, so I didn't transfer it over. All right, so let's change that up. Thank you very much. Okay, yes, of course it has a square on it. So now we're at x squared, okay, plus 4x minus 1. There we go. That looks much more better. Okay, so go ahead and, can we factor that? Okay, are there two numbers that multiply, and I forgot my x, let me just write it in. Are there two numbers that multiply together to give me -1 and add to give me +4? Okay, not any combination that I can think of, so yes, indeed, that means we're moving on to the quadratic formula to solve this. Now, in this case, okay, the question here, verify the solutions rapidly. Okay, that'll be so much nicer because our answer, right, is probably, if we do an exact answer, okay, then having to substitute that in, it'll get a little messy. So what we're going to do is, after we substitute in, so negative, sitting here, 4 plus or minus 4 squared plus 4, 1, okay, here, we should have, okay, 4, -4 plus or minus root 20, so root 2. Okay, so don't forget to simplify. I can divide everything out by 2, so we should have -2 plus or minus root 5. Okay, so if in this case, you could say that this is approximately equal to, these are two squiggles. Okay, this you can do on your calculator to get a decimal approximation. Because we're going to be checking with the graphing calculator, it's going to give us a decimal. So that's what we want to compare it to. Okay. So head over to your calculator, Okay, let's put that. So we have -2 plus root 5. Oops. Okay, so 0.24. Okay. Okay, so the two squiggly lines means approximately equal to, because we're taking an exact value, and we are converting it into a decimal. So -2 minus root 5, -4.24. Oops. Alright, so we head over to our calculator. Okay, y equals, okay, on the left hand side we're going to do the square root of, oops, square root of 3x squared plus 2, okay, y2 equals, that's where we're going to put 2x plus 1, okay, and we go back to our solutions that we just wrote down, okay, and we're looking at like a decimal, 0.24 and, -4, so I'm thinking that our standard window will be just fine. So I do zoom 6, okay, and I've got my graph. I'm looking for my intersection. So if I go second trace, okay, and okay, let me go back to my graph because, okay, it's a little hard for me to see that there's actually two solutions. Okay, so you might have to zoom in a little bit for that. Okay, so I might go, I don't know, 5. I don't know that we have to go all that much. Okay, that looks a little better. Okay, streamline. Okay, that looks good. This one. Okay, so second trace. Okay, when I do my intersection, first curve, second curve, and my guess, okay, I get the 0.24. Okay, so this one, okay, is my solution. Guys, did they intersect at -4.24? No, so that's my extraneous solution. It's like not there. Okay, so that was algebraically, right, there was an extraneous solution introduced, and when we graphically solve it, this is what it looks like graphically when there's an extraneous solution. Okay, it doesn't show up, because if it did show up, then it would be a real solution. But because there's no intersection at -4, okay, then we can take this one, okay, and say that this one is the extraneous. So that's the difference between verifying algebraically, where you would sub it in, left side doesn't equal right side, and graphically, there's visually no solution.
I don't know if there's a reason for this, but is there a reason why the line is so much more like harshly curved than it's usually?
Yes, because it has there's a radical in it, as well as
So
a square. Yeah, oh yeah, you're introducing all kinds of fun. In fact, we'll explore a bit more later. Okay. All right. Okay, for our next question, okay, it says note that there's a negative in front of the radical. Okay. So we'll deal with that in a second. First thing we're going to do is, as soon as we're dealing with radicals, we're going to do our restrictions. Okay, we're going to take our radicand and make it greater than or equal to 0. Okay, so m has to be greater than or equal to -3/2. Okay. So in this example here, when we're isolating, okay, we want the radical isolated, but we want it to be positive. Okay? So what I want for us to do is we're actually going to take this m minus 2m plus 3 equals 6. We're going to take this and we're going to move it to the other side. Okay? And then we're going to move the 6 over. So the same, like the way that we normally do, okay, so we're going to have m plus 6 gives us our 2m plus 3. Okay. We just want to make the radical positive by moving it. Okay, then we can, now it's isolated. Let's do this color. Now we can go ahead and square both sides. So we have m plus 6 times m plus 6 is equal to 2m plus 3. Minus 2, okay, negative 12. Oh, there we go. Do this again. Give me a sec. See, I'm correcting my own errors. Do that. Okay. There we go. Okay, yes. When I got the 6 over, I forgot to subtract the 6. So that's where my negative sign came in.
Oh.
Yeah. Okay, so in this case, okay, we could jump right into quadratic formula, but let's just double check if we can products on this, just for a little bit less work. Okay. I'm thinking if when there's 33, really we've only got like 11 and 3. Okay, can we get to negative 14 with an 11 and 3? Sure thing. We can do negative 11 and negative 11 and negative 3. Okay, those are our two possible solutions. Okay, I'm just going to take up the space here. Okay, I'm going to verify. My writing today is very okay, into the original equation. So the right side is easy. The right side is just going to stay 6, and let's sub in 11. Okay, 22 plus 3 is 25. Square root of 25 is 5. Okay, so the first one looks good. Okay, and then we're going to do the second one. Right side. Go ahead and verify that along with me. We've got 3 minus 6 plus 3 gives me 9. 3 minus 3 will give me 0. Okay. Okay, so in this case, my verification failed, so my second solution is extraneous. Okay, let's do another question on the board. I have 2 for you. I'll give you a moment to write that, and then we're going to do this little guy right here. We're going to do them up on the boards. Okay, so this one is says collision investigators approximate initial velocity v in kilometers per hour of a car based on length L in meters of the skid marks. Okay, so give you this lovely formula. They've already given you the restrictions. Okay, this models the relationship. What length of skid mark is expected if cars travel 50 kilometers an hour when the brakes are applied? Okay, express your answer to the nearest tenth of a meter. Okay, so we're looking, here's our original equation. 4.6 root L, okay, plus 8. Okay, and it tells us we're substituting in the velocity is 50. Okay, so go ahead and isolate your radical. Okay, so we want to subtract 8 from both sides. Okay, and then we're going to divide both sides by 12.6. Okay. Now, if possible, okay, again in this question it works out in the end, okay, but if possible, we want to save the rounding to the very end, to your final answer. So don't round the in between. Because when we do 42 divided by 12.6, whoops, not there. Let's try in our regular, there we go. If we do 42 divided by 12.6, okay, you get this nice repeating decimal. Hopefully you look at that and go, oh, that's repeating decimal, that's fraction. Okay, so you could easily go math fraction, okay, and just leave it as 10 over 3. Okay, or you can let your calculator carry all the decimal places until your next thing, like, so just don't round until the very end. Okay, so since I know that it's 10 over 3, I'm just going to go ahead and do that. Okay, now I'm going to square both sides. Okay, move over the L. Okay, and it does want it to the 10th of a meter, so go ahead and convert it back to decimal form. Okay, problem solving questions, yes, and sentence answer length of the skid would be. Okay, make sure that you are looking at units, you are rounding correctly, and away you go. So, go ahead and grab your textbooks. We're going to be doing page 300. Okay, the questions are, so we're going to be including these questions along with the ones that are on the bottom of the previous page. Okay. So all the questions on page 300, okay, and you guys have